ठीक है, वो है कोनिक सेक्शन में विल prove an very important and crucial property which is length of semi-lattice rectum is harmonic mean between the two focal lengths. और ये प्रॉपर्टी यू मस्ट हैव सीन इन ऑलमोस्ट ऑल स्टैंडर्ड टेक्स्ट बुक. यूजुअली इसको हम पैरामेट्रिक फॉर्म से प्रूव करते हैं जो कि आपके कोचिंग्स में किए जाते हैं, बट हियर आई एम गोइंग टू प्रूव इट इन अ ज्योमेट्रिकल फैशन. मोर एवर विल नॉट सेपरेटली डू इट फॉर पैराबोला, एलिप्स और हाइपरबोला, जबकि ये जो प्रॉपर्टी है वो तीनों के लिए इक्वली वैलिड है. सो फर्स्ट लेट मी स्टेट द प्रॉपर्टी. सपोज वी हैव पैराबोला, ellipse and hyperbola, these three curve. So we know we'll have two focus in case of each ellipse and hyperbola. Let's call S1, S2. So the property goes like this: if you have any focal chord, 1 by SQ will be 2 by length of semi-lattice rectum. So in case of parabola, length of semi-lattice rectum will be 2a, while in case of ellipse and hyperbola, it's going to be ba square by a. Of course, I'm doing it with respect to the standard ellipse and hyperbola where a is more. ठीक, अब इसको हम कैसे प्रूव करेंगे? और ये जो प्रॉपर्टी है वो वैलिड है इवन आप कोई दूसरे फोकस ले लो उससे भी, राइट? सो इवन वी कैन हैव पॉइंट p dash q dash and what is constant is 1 by sp plus 1 by sq ratio. So it's basically it's kind of intersecting chord theorem for conics, right? So all these ratio will be variant. If I take p dash q dash, so what I can tell is 1 by sp plus 1 by sq will be same that 1 by sp dash plus 1 by sq dash will also be same as, let's say, p double dash and q double dash plus sq dash. A conic is a locus of point in plane R2 means xy plane such that its distance from a fixed point, which is known as focus, and a fixed line diatrix is fixed, which is known as eccentricity. So for a case when S is not the part of this line L, which is diatrix to call, then so for the first case when S does not belongs to L, the line L diatrix and the fixed point focus will be separated. So now if I have any variable point such that PS by PM ratio, so for any variable point SP by PM ratio is called eccentricity. And since we know for E equal to 1, it will trace a parabola. For E less than 1, we'll have a closed curve ellipse, and E greater than 1, we'll have two branch hyperbola. There will be other situation as well when S belongs to L. So when focus lies on diatrix line, under this situation, if I have any point P such that SP and PM length are equal, so E equal to 1 will give a line, a pair of intersecting line. E less than 1 is not possible because you want PM to be greater than SP, so that will give empty set, and for E greater than 1 you will get two intersecting line at an angle theta. Orthogonal projection from point P, and let's call this as P dash. Similarly from Q, if I'll draw perpendicular, it's Q dash. Now we know lattice rectum is a line which will be perpendicular to focus and parallel to directrix line because perpendicular to axis as well. So let's call this point to be R, and hence its projection will be R dash, right? So now if I consider two triangle, so let's consider a triangle over here, this projected distance, and we have another triangle over here, right? So if I give the name as, let's say, D and E, so now I can clearly see from this picture, if I call this distance as x, SP as x, so hence PP dash will be E times of x, where E is eccentricity of this conic. Don't misunderstand this with parabola, it's general conic, okay? Can be even ellipse part or hyperbola part or parabola. Similarly, if we have SQ as y, so this guy is going to be EY. Exactly in the same fashion, what we can do is, what about this distance? So since total distance is EX and length of lattice rectum is L, so this R dash is going to be EL by definition. Hence, this extra distance which is same as SD, is nothing but EX minus EL. Exactly in the same fashion, what about this distance? So this total distance is EL, and we have this small chunk QQ dash as EY, hence EQ will be E times L minus Y. Now we can clearly see these two triangles are similar. The reason being because these two angles will be equal since EQ dash is parallel to DS, right? From the construction. Hence what I can tell, the ratio of sides. So x divided by y, x divided by y will be equal to ds, which is E times of x minus L divided by E times of EQ L minus 1. E gets cancelled and I have Lx minus xy equals xy minus Ly, which gives Lx plus y equals 2x, implies x plus y by xy. I can divide by x because none of them is 0 clearly from the picture. It's 2 by L, and this gives you a beautiful answer, 1 by x plus 1 by y equals 2 by L, which goes to 1 by sp plus 1 by sq equals 2 by length of semilateral rectum. And in case of parabola, this length of semilateral rectum for a standard parabola 4ax is going to be 4a. In case of ellipse, we know this length of lattice rectum is 2b square by a. Same goes for hyperbola as well. If you want to learn more of this geometrical proof for conic section regions, it is very helpful, especially to understand and appreciate the content. For example, many locus problem of ellipse can be done with pure geometry in 2 or 3 lines. So you can put in the comment section. I'll come with more JE effective videos, especially for means in advance, in upcoming videos as well. Thank you. Have a good day.